Yes, please. Uh, uh, Today we will talk about variable frequency drives. One thing, interrupt me anywhere if you have any doubt. You can interrupt me anywhere in between. So, what is your idea about this variable frequency drive? I just wanted to know.
थोड़ा सा frequency गड़बड़ है. Sound is mismatching.
Hello. Okay, we can proceed. So, we will be covering variable frequency drive, how it is useful, types of variable frequency drive, different components of VFD, the advantages and disadvantages. Every technology has its advantages as well as disadvantages. So, what do you think? Why any motor requires speed control? It's a method of speed control variable frequency drive. Why do we require speed control of any motor in the industry? Yes, please.
Comes many industrial loads,
Yeah.
because in industry very much induction motor is used, and
Yeah.
loads are very lagging in nature.
Okay.
So this purpose induction motor is also used.
Yeah. That is means for induction motor. But why we at all require speed control?
But speed control basically we done voltage and control the voltage and frequency.
No, you are telling the methods of speed control. I am telling why we require speed control at all. What is the requirement of speed control?
सर फ्रीक्वेंसी में vary due to load.
Yes.
That's why we need speed control.
No, basically we require speed control from the means fluid side or for different mechanical regions. Like you have suppose flow is there or there is a pressure is there in the line. So you want to change the process parameters. So for changing these process parameters, we require speed control. You can do it from pump side or you can do it from motor side. So it is always easier to do it from motor side. Otherwise, we have the mechanical means of speed control. So this is on the motor we are doing electrical speed control. There are other methods also of speed control. What are their methods? Other methods apart from BFD? How can we do speed control of motors?
DB, DBVF method is also employed. Variable voltage, variable frequency method.
That is means very much similar to BFD. Other apart from BFD, there are other methods like
The 3-point method, 4-point method.
there are other methods like you can change the resistance or you can change the number of
Yours,
poles of
sir.
different methods. But there are some advantages of VFD that we will see. Now coming to the what is VFD? What we are doing in VFD? As the name suggests, it is variable frequency drive. So what is the formula for speed of the motor? For if you want to determine the speed of the motor, synchronous speed of the motor, what is the formula?
N is equals to 120 F by P.
Yeah, very good. It is 120 F by P. So if you number of poles you can change, but number of changing the poles is not easy, and you can change the number of poles in the multiple by two only. Whereas frequency you can change to any value, and it will give the means long range of speed control. So I'm just means starting with what is starting of synchronous motor. We have two types of motors: induction motor and synchronous motors in AC motors. And as one of the participants has told that induction motor is very common in industries, and synchronous motor is less common. What is the problem with the synchronous motor? Why it is not used in industry?
Starting torque is zero, sir.
Starting torque?
Starting torque is zero because any additional arrangement is required for starting the synchronous motor. But
Yeah,
in case of induction motor, is automatically starting.
yeah. That's the very basic reason. Means induction motor is self-starting, whereas synchronous motor is not self-starting. So in industries, you will not like any motor which is not starting, or you will require separate means of starting the motor. That's why we do not use means have very limited use of synchronous motor in industry. Now the basic question, why it is not starting? You told that the starting torque is zero. Why the starting torque is zero? Any reason?
There is in synchronous motor there is no magnetic locking at the time of starting.
Yeah, very correct. Why there is no magnetic locking? What is the problem?
Uh,
Repeat the question, sir.
Uh, why there is no magnetic locking in synchronous motors? What is the problem?
stator EMF is rotating at synchronous speed.
Yeah,
For
Sir, because
for magnetic locking we have rotor EMF
sir,
also.
sir, because in case of synchronous motor, we provide rotor is a DC supply, but
yeah,
stator is AC supply. This
yeah,
is a one type of oscillation or hunting is occurred.
yeah. So you are very correct. In stator, we are giving AC supply. So this these poles are means oscillating at means synchronous speed. So there is a now, pole changing at synchronous speed, whereas rotor is having DC supply. So they are behaving like a permanent magnet. So in synchronous motor, there is no self-starting torque and cannot start by itself. So if you see the picture uh, in the first diagram, we have given suppose AC supply to it's a stator and a DC supply in the rotor. So in the rotor, there are north and south poles are there, whereas in stator, like at A point there is north pole and at B point it is south pole. What will happen after half cycle? After half cycle, there will be pole reversal, and north pole will become south pole. At point A, there will be south pole, and at point B, there will be north pole. So now, first there was a means torque was in anti-clockwise direction, but after half cycle, the torque will be in clockwise direction. So this will be very difficult to pick up the speed rotor in a very short time. So it will be just torque will be oscillating and rotor will not rotate at all. This is the basic reason. Now with the variable frequency drive, how we can start it? Yes, please.
By reducing the frequency, speed will stator EMF, stator rotating field will reduce.
Yeah,
From that we can avoid the oscillation.
yeah, you are very correct. Now the half cycle for a 50 cycle per second. What is the time of the half cycle?
That point 0.02 second.
Yeah. Now, if you reduce the frequency, the cycle time will increase. If you reduce the frequency, cycle time will reduce. So it rotor will get enough time to rotate in the half cycle. And when it will start rotating, suppose this rotor from A position comes to B position and in a half cycle, then it will get locked. And if you slowly get on increasing the speed, it will remain locked and the speed of the motor will increase. Is it clear?
Yes, sir. Yes, sir.
So by variable frequency drives or by changing the frequency, we can start a synchronous motor means in an easy manner. Is it clear to everyone? If you have any doubt, you can ask. Yes,
Sir,
please.
one query, sir.
Yeah.
In case of synchronous motor, we also use damper winding for reducing the oscillation.
Yeah.
Yes, sir.
It is another way to nullify the hunting or oscillation.
Yeah. There are other means of also for start the synchronous motors also. Like we can start the synchronous motor like an induction motor by giving another winding in the rotor, starting it like induction motor. Similarly, like with the help of damper winding, we are reducing the oscillation. So there are different ways are there. But this is the variable frequency type that is the easiest manner in which we can start the synchronous motor and have a complete control over the speed.